Some of you have pointed out that I'm not that good of a machinist, and I'm not going to argue with you. I don't disagree. I am a very inexperienced machinist. But other people have also pointed out that I am taking some really difficult, just like downright stupid parts. I haven't been able to show you a bunch of those parts on here because of NDAs and stuff, but I assure you, I'm taking some dumb parts that a good machinist, a great machinist in their right mind probably wouldn't be taking. And I think I need to explain why. The answer is I'm trying to get better at machining really quickly here. I don't know how much of you know about Design the Everything and what happened with that, but basically I had a product business. I tried to make it work for a really long time, and I just couldn't get it to work. I was about ready to go back to a normal day job, but as kind of a Hail Mary, I passed that off to a guy I was working with at the time, Scott, so that he could at least keep it going at a lower level in the background, and I could still keep making parts for him. And this Xometry work and trying to set up a job shop was basically my Hail Mary of trying to stay self-employed and not have to go back to a regular job. Now, if I have to go back to a regular job, it is what it is, and that'll be fine. I'll be perfectly happy there, just like I'm perfectly happy here. But I knew the only way that I was going to make this job shop work is if I just went all in. I went for everything. I did not hold back. And I took stuff that was, maybe a little bit above my skill level. That's how you get better, is by pushing yourself. That's the name. That's why we ended up with the name of the shop, Audacity Micro. Do I necessarily know everything that I need to know? Probably not, but I have the audacity to try. So that's where the name comes from, and that's where this shop is. If I fail, it's a very real possibility that I go end up with a day job again. And honestly, I'm fine with that. If this fails, I'm okay with that. I can go back to working for somebody else. But I've been enjoying being self-employed, and I would really like to keep that going. So on that note, we need to make some parts today. First things first, I'm going to get more carabiners running on the tormach. I've got still a whole bunch that I need to finish off there. I need to process all of these blanks into carabiners, so I'm just going to keep them flowing for the rest of the day. I just remembered that I wanted to tweak that program before I hit cycle start on this. I'm having trouble with my chamfer tool, and just the way the tool path works, I have to cut with the very tip of the chamfer tool, and it keeps breaking the tip and scrapping parts on me. So I'm going to change from a regular 90-degree chamfer tool to a ball mill. That should deburr it just fine, but because it's round, it's more supported, and it shouldn't have the same tool breakage issues that I've been having. It also eliminates a tool from my ATC and just my inventory in general, which is always a bonus. Okay, that took me 45 minutes longer than I intended to get the programming set up, but we can now hit cycle start, and as long as things don't crash, we're good. This should improve the quality of the product quite a bit. There were things that I wasn't chamfering before that I am now chamfering. It'll be a little bit of a pain because I'm going to have to put in some screws, do some chamfers, move the screws, do some more chamfers, and then put in all the screws and hit go. So it's going to take some extra time. But I was constantly having issues with burrs on these carabiners, and if I can do less hand deburring, that'll be worth it in the long run. Plus, it'll just be a better quality product because it'll have chamfers, everywhere, and not just relying on me neatly deburring, which you can only be so neat by hand. And we don't have to have the process reliability issue of that little chamfer tool breaking. Let me show you what I was using. So I was using a drill mill because it's the only one I could find that was both cheap and had a nice sharp point. And the problem was that sharp point would break all the time. These would not last for more than a pallet or two. And the way they fail tend to scrap carabiners. So I think with a ball mill, normally the way those fail is they just get dull, at least in running them like this in titanium. They tend to not break. So I think I'll have kind of a slower failure curve that I'll be able to watch and just see when it starts to leave more of a burr or the finish gets bad. and then I can replace it instead of just running it until it's like, oh, look, the carabiners are bad. It's always better to have things fail in a desirable, controllable pattern. Speaking of undesirable failure, I have a lot of tools broken in my ATC at the moment. I ran a part overnight, and this right here is the roughing end mill. I'd actually like to know how and why it broke and why it looks like this. Because it broke, and then that tool broke, and then that tool broke, and then that tool broke, and that tool broke, and that tool broke, and that tool broke. So probably like $300 or $400 worth of broken end mills in my machine right now. So that's a little bit unpleasant. I don't think anything that's in there is irreplaceable. I think I can still finish off this part. I don't know why it failed, which is a little bit scary. But what that means is I really need to figure out tool breakage detection on this machine. It has the tool setter, it can do it. I've never figured out how, and I'm gonna do that now. So it looks like in my post there's an option for tool breakage tolerance, but I don't see an option that just does the tool breakage checks automatically. So I'm gonna see if we can add those as a auto NC, or a manual NC, the opposite of an auto NC. Okay, sure enough, as a manual NC, I was able to add a tool breakage check. This is the code it posted. I'm gonna now compare this to what the conversational on the machine develops, just to make sure everything is right. So over at the controller, I can hit edit, open up the conversational menu, go to tool setting, and then down here, there's tool breakage control. And if I type in the tool number and the tolerance, I can add that to my MDI line, and this is what it generates for me. So in theory, this should match what the computer generated. And I didn't look over there, so I'm gonna have to manually compare this. Turns out they're completely different. So I'm gonna go see if I can figure out what this macro would do on that controller. Maybe this still does the same thing or the right thing, just with a different way of getting there. Maybe this does nothing, maybe this crashes my machine. So I'm gonna go look up this macro that it's calling and find out. If that doesn't work, then I'll have to modify my post. All right, we have answers, and I think it'll work. These Renishaw probing macros are kind of a maze that all like calls other programs. It's like one program will call 6 different other programs to get the job done. Now, I think what's happening is the MDI line on here, the conversational on here is calling a master program, providing it with some information telling that master program what it wants, and then that master program is calling a sub-program that does the actual tool breakage check. Inside that master program, it seems to call the exact same line that I wrote here, which is what the post processor is calling. So basically, the post processor is taking the role of that master program and just calling the exact program it needs to do. It needs to call instead of calling the master program, which then calls the tool breakage check. So I think it'll work, is basically what I was saying there. Renishaw programs are complicated, just the way they're written. It's not just like call one program to do one thing. That's really what I wish they were. I'm sure they have it set up this way for like ease of editing. Like if you wanted to edit, exactly how it touches the tool setter, like you'd want to edit it in one place instead of editing it everywhere. But man, it's complicated to wrap your head around their macros. But I suppose we should do a test. So I'm just gonna have it spit out from the computer a tool breakage check for a tool that I know is good. We'll run that tool breakage check and keep our fingers crossed that nothing breaks. Like my very expensive tool setter. I would be in trouble if that broke. All right, let's turn the feed rate way down. Let's turn the rapids down. I don't actually know if the macros obey this, but we'll find out. And I'm going to hit cycle start. I have the door override turned off. Coolant shouldn't turn on. Fingers crossed. I think this is going slow. Here, what happens if we turn down the feed more? It goes slower, okay. So it does obey the feed rate. My finger is hovering over the feed hold. So maybe I could have it go a little bit faster. This is a 20% override. I think it should be fine. If it's gotten this far, it should be Oh, that didn't seem to obey the feed rate. That's interesting. Oh, okay. Because this is controlled by the rapid. There we go. What happens if we do it at full speed? Why does it stop and then go faster again? That's weird. Alright, well, tool breakage check seems to work. Alright, here's a question. What happens when it fails? So I've taken the tool holder out, which will simulate a broken tool. What does it do now? Don't crash, don't crash. It should know to stop. Aha. Okay. And we've got the blinky red light. So, tool breakage detection works. That was easy. Well, that could have saved me like $300 if I had taken the 20 minutes a couple days ago, but sometimes you just need a kick in the pants. I just finished putting all of the tools in their tool holders, replacing all the broken ones. Turns out I broke 5. I have direct replacements for 4 of them, and I'm just gonna have to kind of improvise for the 5th one. I think I can make do with a smaller tool though. I then promptly got distracted by Renishaw macros. I have a job coming up, it's probably the next thing that I work on, and it has one of these end mills. This is a Harvey long reach 10 thou diameter end mill. It's about 2.5 pieces of paper thick. I am worried that how fast my machine touches off on the tool setter will break that tool. It's also a $60 tool, so not only is it incredibly fragile, it'll be incredibly easy to break. So that led me onto a deep dive into the Renishaw macros. I was really hoping there would be like a settings program where it would take the feed rate from and it would just propagate down to all the other programs. It doesn't seem to be that way. It seems to be hard-coded. It's hard-coded at 1,000. I don't know if that's millimeters or inches. I think it's millimeters because they also, I think that must be 1,000 millimeters per minute, but then they multiply it by a conversion factor, so like 400 inches per minute, which is definitely fast for setting off a 10 thou tool. So I'm going to manually put in my own override value. I'm going to lower that down maybe by 1/3 and see how that works. Hopefully I don't crash anything, but I think I know what I'm doing here. So I'm not sure if it's going to show up here, but this line right here, G31, Z number 28, and then F, or variable 28, and then F variable 9. I believe a G31 is a probing move. The Z height is taken from some other variable. It's calculated somewhere else. And then the F would be the feed rate. So it's saying that it's going to feed at whatever the value of variable number 9 is. If we go up here, I can find the value for variable number 9. It is 1,000 times this variable 29. The 29 is the metric to inch conversion factor, which is, they just use 0.4. So I think if I change this variable up here and I multiply this by some other factor, I can change the feed rate on all of the probing cycles. So I believe I can just type in now times, and let's do 0.33, and then if I hit insert, that should go into the right place there. So there's my my modified code, and then I'm going to put a comment here with my initials A, J, H, and that will show me that I modified this so I can find it in the future, hit insert again. Okay. Now I noticed that there's a couple of different feeds. I assume roughing probe versus the fine probing, and currently they're set to be the same speed. So yeah, right here. This is the, nope, that's not it. Anyway, it's somewhere else, and I'm gonna go change that other line too once I find it again. Now, if I was smart, I would make that multiplication factor, in this case I'm using 0.33, I would make that a variable that I could adjust at the top of the program, but I don't know what variables I can use. I'm not comfortable just guessing. I'm used to variable programming over on the tormach, where I know what variable ranges are safe. I just don't know what's safe on this machine. I'm sure I could look it up. But I know this will work without risk of unexpected consequences. Okay, let's check if we broke anything. I'm going to do this with a big tool. Though maybe it'd be smarter to do it with a small tool. Alright. I did a feed hold because I got nervous. That may have actually... I don't know. Well, I let it go, and it seemed like it was slower, but I apparently have broken something. Unbalanced brackets and expression. Whoopsies. Let's get that cleared and jog the thing away. All right, now let's go find my mistake. All right, and now since I marked everywhere I made a change, I should be able to just kind of go down by searching for my comments, which I don't know if there's an easier way, but the way I do it is I just type in my initials down there, then I hit down and it'll bring me to the next one. I wish there was a way I didn't have to type it in every time. There probably is, but I don't know how. And right here is our mistake. I just somehow lost or probably replaced that bracket with my comment. So I'm gonna put that bracket back in and we should be good to go. All right, let's try again. I also slowed it from 1/3 to 25% speed. So it should go even slower. That feels slower. Maybe not a ton, but a little. This part's definitely slower. Yep, nice and slow. Well, it took an hour of fiddling, but I finally have all the speeds for all the various steps where I want them. Nice and gentle, a little bit slow, but not excruciatingly slow. So I'm good with that. It's kind of a cold, rainy, drizzly day today, so it's a really good day to get some work done in the shop. Today's Sunday, so I'm not going to spend too long out here, but I have a lot of parts due early in the week next week, and anything I can get out of the way today will make next week so much easier. I know I never closed the loop on that titanium part, but it's good, it's done, it's gone. We don't have to worry about that anymore. Sorry for not getting the rest of that on video. Today, we are working on some stainless parts. I don't remember if what I've shown of this so far. This has been a couple days since I last recorded a video and, you know, memory. However, the op ones are done and we are, oh yeah, I showed all the tools that were broken in the ATC. That's those parts. We're gonna finish up those parts. These parts are pretty simple. Here's my sketch for you guys that is a NDA safe. I'm not a very good artist. Basically, it's a rectangle with a hole in the middle. So we have done this part, and so now we just need to do the backside. The backside is very similar. We just need to face off the bottom, and then on this side here, there is like some surfacing work that needs to be done. Pretty simple. Most of our major tolerances were already hit in the first op, so not much going on in the second op. The one exception is there's a pocket, it kind of goes like here, and the inside radius of those corners there is 0.5 millimeter, so 0.5 millimeters. That translates to 1 millimeter end mill, which translates to 0.04 inches, so 40 thou. Now I have a 1/32 inch end mill that I'm going to use to cut those corners. But, you know, not cutting corners, because that would be wrong. The only downside is I just broke my only reasonable 1/32 inch end mill that had enough stick out. So we have to go to the unreasonable 1/32 inch end mill. And that is this guy. This is, I think, a 3/4 inch, maybe 5/8 or something, stick out 1/32 inch end mill. It's a little bit scary, but honestly, this machine handles this stuff really well. And you want to see scary end mills, look at this end mill that I have for next week's job. So if we step over here to my microscope, here is the tip of a ballpoint pen, and that little line right there is the end mill. That is a 10 thou end mill. So yeah, that thing's terrifying, especially because they cost $65 each. I only have 2 of them, and the part is due on Thursday. So I don't know if I'm gonna have time to get more if I break those. So lots of caution is called for that. Oh yeah, I'm also gonna be using them in the bottom of a 2-inch deep pocket. So I am actually really looking forward to that. It's kind of terrifying, but it'll be fun. I did get this thing. Look at this. This is a collet adapter that gives a ER16 collet a longer nose. And that's what I'm going to be using to hold that end mill. One, it lets you dial and run out, which is kind of convenient. But two, it gives the end mill extra support to get way down inside that pocket and hopefully doesn't introduce too much run out, because even a tiny amount of run out on that tool will break it. So I actually don't even know if I have an indicator sensitive enough to really dial that in. That's probably another metrology investment I need to make, along with 1,000 other metrology investments. This setup isn't going to be anything wild for the Op 2. Basically, we're just using traditional vice mode on the mod vices. Now, good news is my new vice was scheduled for delivery yesterday. Bad news, as you may have guessed by the term scheduled for delivery, is that it did not show up. I doubt it'll be delivered today, Sunday, so hopefully it'll be here Monday. And it's not exactly a traditional vice, but it is more traditional than the mod vice and will hopefully save me some of the setup time where, you know, I'm flipping between serrated mode and regular vice mode. And also, it'll just be less screws to tighten and to adjust, and it'll just generally be faster. So I'm looking forward to that getting here. Like I said, the mod vices, they're pretty good at just about everything, but they're not the best at anything. It's kind of how I feel sometimes. But they will do just fine for this. I do think Op 2s are their weakest point. I think there's too much jaw lift in them to get something super, super accurate on the first try. But they're not too bad, especially if you don't go gorilla mode on the screws. And we should just have to snug these forwards a little bit and be good to go. So to get the moving jaw set up, I like to just stick my part in there and push it up against it and then tighten down these screws. And that gets just kind of the general spacing sorted out. And then, of course, we can tighten these screws when it's time to actually make the part. But first, we need to put parallels in here and set our work coordinate system. Parallels have always bugged me. They've been annoying. I've just always found them annoying that they like to run away on you when you change parts. So what I've started doing is I have these little magnets here. And once I make sure everything's clean, I just stick my parallels to the magnets, make sure the magnets are below the surface. And that does a really good job at keeping the parallels in place. It also spaces them away from the vise a little bit, which can be handy sometimes. I can't think of an application right now, but I've had times where I needed that spacing, or even there's been times where I have wanted the parallels to be kind of close to each other, so I have just taken magnets and magneted two parallels close together. That kind of makes like a beam. I don't remember why I did that, but it came in handy once, so it might save you once. And now I have boogered up my magnets here. But I know you can buy little springy clip things, or make them if your vise is kind of close together. I also know that you can just stick them to the edge with grease, and I have done that before. That works really well, actually, sticking them to the side of the jaws with grease. But magnets is cleaner and quicker and easier as long as you're not cutting something ferrous. I never cut ferrous material. Well, okay, I should say I never cut magnetic materials. Stainless steel is, of course, ferrous. But I generally don't cut the magnetic varieties, so I don't worry about chips building up there or anything. If you're running, 1018, maybe stick with the grease method. But for what I do, this works really, really well. So now I can put it in there, and it'll be easy to open this up, and I can move my part, and my parallels don't run away on me. Okay, and then the other thing I do is I use this vice stop here. This will be my Y0. My X0 is on this fixed jaw here, and then my Z0 is at the top of the parallel. So I just have to make sure that this Vice stop is poking to the right spot. Which, right there it is. I don't even have to adjust that. I really like this vice stop from Kowalski Machine for the Saunders Machine Works table and mod vices. I have had zero complaints with this sucker. It has just kind of always done exactly what I needed. And makes parts like this fairly quick and easy. Okay, let's just make sure that everything tightens down well. I don't know why it wouldn't, but just kind of a sanity check here, and then I'll set my work coordinate system. All right, on to the wiggler to set my work coordinate system. You've seen this a million times before, so I'm not going to show it on camera, but I'm just going to touch off there on my fixed jaw. I'm going to touch off over here on this work stop, and then I'm going to touch off Z on the top of my parallel. While I was setting up the mill, which is done now, by the way, I noticed that this end mill had seen some things in its lifetime. It definitely needs to be replaced. It's a 3/16 bull nose 4-flue end mill. And I use them for when I make pry bars for Design the Everything. For some reason, they worked well in that application, but I've had a really hard time with them for anything else. And I don't know if it's just my feeds and speeds are wrong for different materials, because I do make those pry bars out of a different kind of stainless or what it is. But they work well for me for those, but they don't seem to work well for me for anything else. So I'm going to have to find another 3/16 inch end mill to use for kind of the majority of my material removal for stainless and other hard materials. Well, machine's running, so it's officially lunchtime. I have made a mistake. I can't show you the part, but yeah, I can't show you the part. I thought about it. I made a dumb mistake. I loaded the part backwards. It was supposed to go the other way around in the vise, but I wasn't paying attention. I didn't double check my cam to see which way it went. I made assumptions, and I put it in backwards of where I programmed it. So that's annoying. It did break a tool, unfortunately, but it's only a Jelly Bean 1/8 inch end mill. Well, I can still make the other one, and I'll have to remake the full other part as well. Fortunately, I do have enough materials to make it at least once more, if not 2 or 3 times. So, some wasted time, but not the end of the business. I don't know. Anyway, let's make this part again, shall we? I keep forgetting what I've said in these videos, but at some point I told you that I scrapped one of the parts by putting it in backwards. I finished the other part because I need to make 2 of these, and so I had 2 running. I finished the second part, and now I'm remaking the first part. It's loaded up. The only change is how I've set up my vise, and it's really not that different. I'm using the same work coordinate system that I used for the Ob2s. Since it's already set up, I don't have to change out parallels or anything. All I did was copy it from G55 to G56 and change my Z height based on the top here, because that's how I set up Op1s for some reason. It's probably a dumb way of doing it. I'm pretty sure we're not going to hit the top of the jaws, but that is a possibility, so I will keep an eye on it to make sure it doesn't do so. Other than that, we should be good to go. Oh, actually, there was one more problem. This cut wandered a lot because I cut it up on end, and so the blade had lots of time to do this, and I'm so tired of my bandsaw. That's a different story. But I had to adjust my model of the stock in Fusion to help compensate that. So this is my last piece of material for this job, and I'm really terrified that we're going to spend 2 hours machining only to find out there's a 10 thou little indent because of that bad cut. But hopefully we'll avoid it. We'll find out. Well, good thing I was watching that closely because we almost made a mistake. It maybe would have been fine, but the tool was about to plunge into this material here, and it was because of the changes I just talked about. So if we jog this up, I'll show you what I mean. So to make sure that the part fit in here, I modeled the stock to be the smallest diameter, but what I did not consider is that it would plunge the tool into some of this existing material here that the computer doesn't know about. So let's go fix that in cam, and then we can start this again. So easiest way to fix this infusion is, since I'm already using modeled stock, I just offset that line there. And it may not be immediately obvious on camera here, but now this is at an angle. I just kind of eyeballed it, gave it plenty of extra material so that it wouldn't crash there. That is one advantage of modeling your stock. If you use the built-in like auto-generated stock feature, you can't just tweak it when your bandsaw screws up. And apparently I'm just turning into the I Hate Bandsaws channel, because that's kind of what I feel right now. I left extra material in cam, so it should... Woo. Endmill didn't like that. I don't know if that showed up on camera, but we got some nice bright glowing red there. I had turned up the surface feet, basically the RPM on this cut, because I was impatient and I wanted it to go faster. I'm kind of running out of time on a bunch of different things. This job isn't due until tomorrow, but I've got some other jobs that are also due tomorrow. So I just tried to speed it up, and apparently those surface feet per minute limits on materials do matter. Yeah, okay. The manufacturer recommends 220 surface feet at a 0.8 feet per tooth, or excuse me, an 8/10, so 0.0008 feet per tooth. I was running at 400 surface feet at 1.2 thou feet per tooth. So it handled the feed fine last time, but I was definitely running it too fast. So let's go to 300 SFM. I think it's what I ran last time. Okay, we're actually cutting this time. This is the same tool. The tool seems to have survived. I caught it right away. It was the material getting hot, not the tool, and carbide is pretty heat resistant. So we seem to be good. That'll be ready in a bit here. I'm gonna go do some more cam on my next part. Actually, like my next part. At this point on this job, all we have left is cycle time. So I think I'm gonna end this video here. I couldn't show you the parts anyway when they were done. I think all the problems have been solved at this point. So thank you for watching. I'll see you in the next video.